From the depths of space to the heart of medical technology, radiation surrounds us. It's a powerful force, present in the sun's rays and the treatments that doctors use every day. But what exactly is radiation? What are its different forms? And how do we harness its potential while staying safe? This journey into the world of radiation begins with understanding its three main types: alpha, beta, and gamma. Each type possesses unique characteristics and applications. Join me as we delve into this fascinating world. Let's begin our exploration of these intriguing phenomena. Imagine a tiny particle ejected from the nucleus of an unstable atom. This particle is not just any particle, it is a fundamental component of the atom's core, and its ejection signifies a significant transformation within the atom itself. This particle, composed of 2 protons and 2 neutrons, is called an alpha particle. It is essentially a helium nucleus, stripped of its electrons, and it plays a crucial role in the process of radioactive decay. It carries a positive charge and is relatively heavy compared to other forms of radiation. This weight and charge give it unique properties, making it distinct from beta particles and gamma rays. Alpha radiation, though powerful, has limited penetration power. Unlike beta particles or gamma rays, alpha particles can be stopped by something as thin as a sheet of paper. A sheet of paper or even our skin can stop it. This makes alpha radiation relatively safe when outside the body, as it cannot penetrate the outer layers of our skin. But don't let this fool you. If alpha-emitting materials get inside our bodies, through inhalation or ingestion, they can pose a serious health risk. Once inside, these particles can cause significant damage to our cells and tissues. Despite its potential dangers, alpha radiation has beneficial applications. It is used in various fields, from medical treatments to scientific research, showcasing its versatility and importance. Smoke detectors, for example, utilize a small amount of americium-241, an alpha emitter, to detect smoke particles and keep us safe. This application highlights how alpha radiation, when used responsibly, can contribute to our everyday safety and well-being. Now, let's move on to beta radiation. Unlike alpha particles, beta particles are not made up of protons and neutrons. Instead, they are high-energy electrons, sometimes called beta-minus particles, or their antiparticles called positrons or beta-plus particles. These tiny particles, carrying a negative or positive charge, travel much faster than alpha particles and can penetrate further. Beta radiation can pass through paper but is stopped by denser materials like aluminum. In the medical field, beta emitters like iodine-131 are used in both diagnostic imaging and treatment, particularly for thyroid conditions. The ability to penetrate deeper into materials makes beta radiation valuable in various industrial applications as well. Section 4. Exploring gamma radiation, the powerful waves. The last and perhaps most fascinating type of radiation is gamma radiation. It is a form of electromagnetic radiation much like visible light but with far more energy. Gamma rays are produced by the hottest and most energetic objects in the universe, such as neutron stars and supernova explosions. Unlike alpha and beta radiation, which consist of particles, gamma radiation is pure energy, carried by electromagnetic waves. These waves are part of the electromagnetic spectrum, which includes radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. These waves, like light and X-rays, have no mass or charge but possess immense energy. This energy allows gamma rays to penetrate materials that would stop other types of radiation. Gamma rays are incredibly penetrating. They can pass through most materials, including human tissue and thick concrete walls, making them both a powerful tool and a potential hazard. They can travel through our bodies, even pass through thick concrete walls. This penetrating power is what makes gamma rays so useful in various applications, but also what makes them dangerous if not properly controlled. This property makes them both dangerous and incredibly useful. In the wrong hands or without proper safety measures, gamma radiation can cause serious harm. However, when used correctly, it has numerous beneficial applications. In medicine, gamma rays are harnessed in radiation therapy to target and destroy cancerous cells. This precise targeting helps to minimize damage to surrounding healthy tissue, making it an effective treatment for certain types of cancer. They are also used in sterilization processes, ensuring medical equipment is free from harmful bacteria and viruses. This is crucial in maintaining sterile environments in hospitals and other medical facilities, preventing infections and ensuring patient safety. Section 5. Comparing the three radiations. So, we have explored three distinct types of radiation: alpha, beta, and gamma. Each of these radiations has unique properties that make them suitable for different applications and also pose varying levels of risk. Each has its own characteristics and applications. Alpha particles, for instance, are heavy and slow-moving, while beta particles are lighter and faster. Gamma rays, on the other hand, are not particles at all but waves of pure energy. Alpha particles, heavy and slow, are stopped by our skin, but pose a risk if they get inside our bodies. They can cause significant damage to internal organs if ingested or inhaled, making them dangerous despite their inability to penetrate the skin. Beta particles, lighter and faster, penetrate further and are used in medical imaging and treatment. They can pass through the skin but are generally stopped by a few millimeters of tissue or a thin sheet of metal, making them useful in various medical applications. Gamma rays, pure energy waves, are the most penetrating and are used in cancer therapy and sterilization. Their ability to pass through most materials makes them invaluable in medical treatments and industrial applications, but also requires careful handling to avoid exposure. Understanding the differences between these types of radiation is crucial in appreciating their benefits and mitigating their potential risks. By knowing how each type interacts with matter, we can harness their power safely and effectively. The world of radiation, while complex, is full of wonder and holds immense potential for the betterment of humankind. From medical breakthroughs to technological advancements, the study and application of radiation continue to push the boundaries of what is possible. Section 6. Radiation, a powerful tool for good. The applications of radiation extend far beyond the medical field. In archaeology, carbon-14 dating, which relies on the radioactive decay of carbon-14, helps us understand the past by determining the age of ancient artifacts. In agriculture, radiation is used to develop new plant varieties with improved yields and resistance to diseases. From understanding the vast universe around us to developing life-saving medical treatments, radiation plays a vital role in advancing our knowledge and improving our lives. Section 7. What makes you think about radiation? As we conclude our exploration of alpha, beta, and gamma radiation, I invite you to ponder their significance in our world. Which type of radiation do you find most intriguing and why? Share your thoughts and continue exploring the wonders of science.